This is section 9.3, constant rate of change. So we'll talk about constant rate of change from a table, and then we will switch to how to find slope, which is another name for constant rate of change using a graph. So a rate of change is a rate that describes how one quantity changes in relation to another quantity. In a relationship, the rate of change between any two quantities is the same or constant. This is called a constant rate of change. Table below shows the distance traveled on a zip line tour. Find the constant rate of change between the two quantities. So when the table is sitting horizontally, the top row is the x values, the bottom row is the y values. So you can see that the time is increasing by adding 2 each time, and the distance is increasing by adding 12 each time. So to find your rate of change, you need to take the y value, the change in the y, over the change in the x. And some students in class, I asked them how they can remember this, and they had said you have to take, flying is in the air, so flying's above the ground, and taxi's below. So they have to fly over the taxi, which is y over x. So just remember that. So the change in distance was 12 feet, and the change in time was 2 seconds. So if you simplify that, 12 divided by 2 is 6. I still have feet over 1 second, and we can write that as the constant rate of change is 6 feet per second. And really important, do not forget your units. Okay, you need some units on your unit rate. So I just find the change in the time, the change in the distance, and divide them y over x. So another name for the rate of change is called slope, and it is the ratio of vertical change to horizontal change. So again, vertical goes up and down. That is the y value, and horizontal is left to right, and that is x. So we're still going to take y over x. So we have a Mr. Slope guy, and we're going to fill in the face on him to help us remember there are 4 different types of slopes. So this is what he looks like. The 2 eyebrows, if it's going from left to right, if it's going slanted upwards, it's a positive slope, so that's his one eye. If it slants downward, it's a negative slope. His nose represents an undefined slope, so this U is what's called undefined. Okay, and to help some students remember this, I had said that since his nose is there and the U is on the bottom, which represents undefined, I had talked about it is hard to find the boogie underneath your nose, so you can think undefined there. His mouth is a horizontal line, and then you have these 2 circles at the end, so that represents the slope of 0. So that's how you can hopefully remember the 4 different types. So we're going to find the slope of a graph given 2 points, and we're going to use rise over run, which is again the y over the x. So reading this left to right, it slants downward, so I know this is a negative slope. I'm going to go from this bottom point at 2, -2. How much rise and run to get to -4, 2? So I need to run 1, 2, 3, 4, and so that was a rise of 4 and a run of 6. Now I'm going to the left, so it's going to be a -6, which that reduces to 2 over -3. So that is your slope of that line. The slope formula we'll talk about later on the second day of this lesson. Okay, so let's just do some quick review problems of those 5 concepts. So the first one, find the constant rate of change in the table. Remember taking y over x, fly over that taxi. This is the x, this is the y. the items are increasing by adding 5 each time, and the cost is increasing by adding 12 each time. So if I take the 12 divided by 5, you get 2.4. Now on the problem, we're dealing with money and items, so it's actually $2.40 per item. So remember to put a unit on your answer. The second problem, time is increasing by 2 every time, while the altitude is dropping by 40 every time. So again, take negative 40 divided by 2, which reduces to negative 20 feet per minute. So that is your answer. On the graphs, we can use rise and run, but we have to be careful, and sometimes these graphs change the scale. These are both counting by ones, but I know on the homework, some are counting by 5, some are counting by halves or 100. So we can rise 1 and run 2, which makes it 1/2, because I'm doing rise over run. My rise, the units were in inches, so it's 1/2 inch per, and my run was in weeks, so 1/2 inch per week. The second one about selling coffee, I'm rising 2 and running 1, so that's 2 over 1. My rise was in money, so this is $2, and my run was in pounds, so do $2 per pound. And the last picture is just 2 points. There are no units on this one, so I am just rising 8 and running 2 in the negative direction. So again, if I do rise over run, I had to rise up 8 and go left 2, so that's negative 2, which that simplifies down to negative 4.